Hello, pre-algebra class. It's time for another chow time. This time, lesson 2, words and expressions. Let's start off with some vocabulary. Numerical expressions, also known as algebraic expressions. It's a math sentence that contains a combination of numbers or variables and operations. And actually, this is not entirely true. A numerical expression only contains numbers, whereas an algebraic expression contains numbers or variables. This numerical expressions, though, this is like not so useful because most of the time in math, we're going to be talking about algebraic expressions. Just know that as numbers or variables, but we're not going to be dealing with variables right now, which I guess is what makes it a numerical expression. All right. Some examples of numerical expressions. 2 plus 3. This has numbers and an operation. Numbers and an operation. Numbers and an operation. This operation here is multiply. I'm going to take this opportunity to talk about this right now, actually. In the past, you may have known multiplication to look like this: 2 times 3, or 3 times 4, or 2 times 3, 3 times 4. But we're going to stop using all of that. And the reason is because the x here looks like the variable x. And soon we're going to be talking about things like 2x plus 3. And so it's just good to get out of the habit of using the x because it looks just like the variable x. And why not use the dot? Well, 2 times 3. Is that a 2 times 3? Or is it a 2.3? Well, that's pretty confusing, isn't it? And that's the reason that Mr. Chow and other mathematicians use the parentheses. The parentheses show multiplication with no confusion. Here, my computer doesn't have the divide symbol, or it does, but I don't have time to look for it. But this is basically 3 times 2. Sometimes you'll see it also as this. Sometimes you'll also see it as this. These all mean the same thing. These are all dividing quotients. All right. So the skill that we'll be learning today is translating expressions. Verbal expressions can be translated to numerical expressions. For example, Mr. Chow brought 2 pieces of candy for each of the 23 students in class. So we can take this verbal expression and convert it to a numerical expression. 2 pieces of candy times 23 students. That gives us the total number of candy that I need to bring. Yum. Our next vocabulary word, evaluate. Evaluate means to find the numerical value of an expression. So if you have an expression like 2 plus 3, when we evaluate this, then that becomes 5. Well, when we're evaluating expressions, especially expressions with many steps, like 2 plus 3 divided by, I don't want to use that. 2 plus 3 divided by 4. We have multiple steps here. And when we have multiple steps, there are rules that we need to follow that tell us the order that we want to evaluate the expression. Let's take a look at an example of that, shall we? Nope. First, let's talk about the order of operations. This is how I learned the order of operations. Parentheses, exponents, multiplying and dividing as the next step, adding and subtracting as the next step. We don't really use parentheses in the textbook. We call it grouping. Parentheses can be grouping, brackets can be grouping, and the division bar or the fraction bar can be grouping. The reason I call it parentheses is because there's this mnemonic. There's this way of remembering this. It's called please excuse my dear aunt. Oops. Geez. Sally. PEMDAS. PEMDAS. Parentheses, exponents, multiply, divide, add, subtract. This may not help you. Actually, when I was young, I think I just memorized the steps. And that's totally fine too. When you have a step like multiply and divide, you perform the operations from left to right. So if you have 2 times, I just told you not to use the x. 2 times 3 divided by 4 times 5. Well, you're going to do this from left to right. Same with addition and subtraction, left to right. Oops. All right, so let's take a look at this example. Oh, so complicated. What do we do first? Well, the grouping. The grouping comes first. 3 minus 2 is 1. So we just bring the rest of this down. Then we do exponents. We don't have any exponents. Then we do multiplication and division from left to right. So look, we have a 3 times 1 here. That stays a 3. Then we have a divide by 2. 3 divided by 2 is 1.5. Plus 3 divided by 2. Here we have another division. Oh, look at that. That's another 1.5. So we just bring the rest of this down. Now we can just add from left to right. 2 plus 1.5 is 4.5. Plus 3 and 3. Plus 1.5. 4.5 plus 3 is 7.5, plus 3 is 10.5, plus 1.5 is 12. So there we go. We've evaluated this expression. Congratulations. Next, let's look at this example, this real life type example. A cell phone company charges $20 per month and 15 cents for each call made or received. Write and evaluate an expression to find the cost for 40 calls. Then make a table showing the cost of 40, 50, 60, and 70 calls. So first, we'll write the expression for 40 calls. Well, the word expression, the verbal expression was $20 per month and 15 cents for each call made or received, right? So it's going to be $20 no matter what. If we make any phone calls or not, it's going to be $20 a month. Then we add the 15 cents times the 40 calls. So we do 15 times 40 first, and we get 6. Then we add the 20 to that, and we get 26. And then we can make a table here for all the different number of calls. 50, 60, 70, to give us all these total costs. So as we can see here, there's a pattern emerging. As the number of calls increases by 10, the cost increases by $1.50. Interesting. Let's do a got it problem. Oh, and by the way, these are in your book. I'll get the page number while I'm doing the next problem. All right. So the same phone company offers another plan where they charge $15. So it's a little bit less money per month, but they charge more for each phone call. write and evaluate an expression to find the cost of 40 calls during 1 month. So still going to be $15. This time we're going to add 0.25 multiplied by 40 calls. So 40 times 0.25, that's 10, plus 15, this is $25. Then it asks us to make a table showing the cost for 40, 50, 60, and 70 calls. So just like in the previous, we're going to make this table again. Oopsies. 40, 50, 60, 70. We're going to write our expression and then our final total cost. Let's do it. So number of calls, 40, 50, 60, 70. Then we're going to write our expression, which is going to be 15 plus 0.25 times 40, 15 plus 0.25 plus times 50, 15 plus 0.25 times 60, and 15 plus 0.25 times 70. So we know already that the total cost for $40 is, or 40 calls, is $25. So let's do it again for 50 calls. Well, 50 times 0.25, that's 12.5. We add the $15 to that. And what do we get? We get $27.50. So look, we see the pattern emerging probably already, but let's do one more just to make sure that what we're doing here is we're adding $2.50. So 0.25 plus 60, or times 60, that's $15. We add the $15 flat fee, and we get $30. So yeah, it is the $2.50 increase per time. So instead of doing it last time, I'm just going to trust in the pattern. $32.50. And there you have it. Have a good day. I'll see you soon. Goodbye.